going to talk about coordinate proofs. Coordinate proofs. Quick review of what we learned. Last class we talked about triangle shortcuts. Triangle shortcuts. So it says here, state what else must be congruent in order for the triangles to be congruent by the given shortcut. So let's look at what is given here. We want side angle side. So we are given trace those please and add the S. We're already given a pair of sides congruent. We can cross that out. And we're given a pair of angles, vertical angles already provided. So we can cross that out. Now we ask ourselves, what else do we need? We need one more pair of sides that squeeze that angle. And there would only be one option to us. That would be these two sides. So what's needed is KI, the segment, congruent to HI, the segment. Let's take a look down here. We want these triangles to be congruent by angle, angle, side. Let's first determine what's been provided. We are provided only with one pair of sides here. So we need two sets of angles. So what I'm going to do here is we need a set of angles, too, that do not squeeze the side, but simply is a tail of one, because angle, angle, side is the tail, not the hamburger. That's the hamburger. That's not what we're dealing with here. We're dealing with the tail. That would be angle, side, angle. So we don't want to squeeze that side between two sets of angles. We just want it to be a tail of one. So let's see what we can do here. We can call these two angles congruent. That would be a pair of angles. And we could also make these two angles congruent. And you can see, if you look at the one, that S is only really connected with that orange angle. So it's an S over here is only connected with that orange angle. So technically that is an angle, angle, side scenario, a tail scenario. Now we just need to name those angles. So this red angle here, we're going to call it BGH. Is congruent. The match with B is F, so we're going to go angle F, H, G. So those are the two red angles. That gives us a pair of angles. And then these angles, we can say angle B, H, G. Is congruent to angle FGH. If you want, in these diagrams, you're always welcome to just add numbers. We could also call this angles 1 and 2, and call this angle 3 and 4 and be done with it. You could always just add numbers to these angles, and therefore say that angle 1 is congruent to angle 2. That was the red angles. And angle 3 is congruent to angle 4. There's no rule that doesn't say you cannot add numbers. You can always add numbers. Just include that in your labeling. Coordinate proofs. In a coordinate proof, the basic idea behind a coordinate proof is we're simply doing an explanation on the coordinate plane. An explanation on a coordinate plane. You're going to explain something using coordinates. And the most common three methods that we work with on the coordinate plane are the midpoint, the distance, and the slope equation, because each of these tell us something. So just as a quick review, how do you find the middle of anything is where you average. So we're going to average the x's, average the y's. Another way to say this is x plus x over 2, y plus y over 2. The distance equation is you subtract the x's, square it, plus subtract the y's, square it. Technically it's y2 or x2 minus x1 squared plus y2 minus y1 squared. But it really doesn't matter which one's x1 and which one's x2. What does matter is the direction you subtract. And of course, slope. Rise, you subtract the y's. Over run, you subtract the x's. Once again, it's usually noted y2 minus y1 equals x2 minus x1. Which one is the first and second point, again, does not matter. What does matter is that you're consistent in the directions that you subtract. Now, what is the significance of these three equations on the coordinate plane? So I want you to actually think these through. I'm going to pause in the video. I want you to try to fill out these blanks. So it says here that if you wanted to show the length of two segments were equal, would you use midpoint, slope, or distance? It says if you wanted to show a segment has been bisected, would you use midpoint, slope, and distance? Last one, if you wanted to show two lines were either parallel or perpendicular, would you use midpoint, slope, or distance? Think about it and fill in those three blanks. Length is a concept of distance. So if I wanted to talk about the length of things, I'm going to use the distance equation. Now what might throw you off is that word equal, because you might think midpoint, but we're talking equal in length. Equal in length. And again, length is a distance issue. If I want to show something's been bisected, when you think bisected, think goes through the middle of something. If it goes through the middle of something, we're talking midpoint. And parallel and perpendicular are concepts of tilt. In this case, that is a slope issue. And as a quick reminder, when the slopes are equal, lines will be parallel. The other notation is when slope times slope equals -1, they're perpendicular. So how does this actually work? We are told that LMN is a quadrilateral with these vertices. And we're going to have two triangles that are congruent. Let's start by plotting the vertices. You always want to draw the diagram first. Make sure you have both the letters and the coordinates. So L is at 0, 0. M is 2, 5. N is 8, 5. And O is 6, 0. So it's a quadrilateral, which means it's a four-sided figure. And let's see what we're trying to prove here. We are trying to prove that triangle LMN, so I'm going to trace that, LMN, that triangle there, we want to be congruent to NOL. It is helpful if you trace this in two different colors. So we want to make the triangles equal. The minute you think of triangles being congruent, you should think of the following shortcuts. Side, 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 angle, side, angle, side, angle, or angle, angle, side. So I want to ask myself, what will help me prove this? If I want to show that sides are equal, to show a side equal, I'm probably going to use distance. That's a distance equation. To show an angle equal, if I can show lines are parallel, then I could work with armpits of the Z, which would be alternate interior angles. So I could work with that as well. And parallel would be an issue of slope. There's really not a midpoint or a bisector going on here, so I'm not going to use midpoint equation here. But I can use the distance equation to show lengths of sides, and I could use the slope equation to get armpits of the Z. And so you really have a choice here. There's no single way to do this. So I'm going to use is distance. And so the first thing I want to do is I want to find the distance of L to M using the distance equation. So I'm going to set up a template. And then I'm going to find the distance of O to N. And I'm setting up a template. That's the distance equation template. Got a little bit larger so it's easy to work with. Okay, now I'm going to plug in my numbers. And I'm going to go from circle my y's. And I'm going to go this direction, top to bottom. So I'm going to go 2 minus 0. Box my y's. Circle my x's, box my y's. I'm going to go 5 minus 0. This, I'm going to keep the same direction. Circle your x's, top to bottom. And box your y's, top to bottom. Now you go ahead and work on the math. And we find that they both have the length of root 29. So now we're going to go this direction, MN. And OL. Set up your templates. And we'll do the math. So now we're going to go x to x going horizontally. So I'm going 2 minus 8, 5 minus 5, left to right, 0 minus 6, 0 minus 0. Work through the math. And we see that MN equals 6 and OL must also equal 6. So what does this tell us? This tells us that we have a pair of congruent sides, so hatch mark put an S. And we have a second pair of congruent sides, hatch mark put an S. And then this middle, trace it real big, that's a freebie. We don't even have to find that distance because it's shared. That's a third pair of side because that's reflexive. So I can do side, side, side here. So as a quick little summary, let's see what we can type out. We want to say that all three sides are equal. So you start with the given information. So I can start by saying I know that point L is at 0, 0, M's at 2, 5, N's at 8, 5, and O is at 6, 0 because it is given. Then using the distance equation, I found that LM is equal to ON, both root 29, and MN is equal to OL, both 6. And I can say also Ln is equal to Ln because it is reflexive to both triangles. Finally, I have 3 sets of congruent sides. So the triangles are congruent by the side shortcut. That is an example of a narrative proof. Another example. Would be the same one, but now using a two column. So we come here and we plot LM and O. And in this, I'm trying to again show these two triangles are congruent. LMN is congruent to NOL. I'm going to use a different method this time. Again, the 4 methods that we could use, again, are side, angle, side, angle, and angle, side. And to show sides, we can use the distance equation. And to connect with angles, we can talk about if we can find parallel lines, then we can get alternate interior angles, also known as armpits of a z. So that's going to be a slope issue. So let's start with the easiest one we have, and that's actually a freebie. We can say that LN is congruent to LN. And the reason we can say that is reflexive. There's actually no math needed for that. It's a little less there. Now the next thing we can do is if I can say somehow that MN and LO are parallel, if I can prove that, then I can get my armpits of the Z going this way. I'm just going to actually give those numerical values to make it easy. I'm going to call those angles 1 and 2. So if I can get those red lines parallel, 1 and 2 are going to be equal, going that way, because of alternate interior angles. That would give us a pair of angles. And then if I could show the lines are parallel going this way, I would get armpits of the Z going horizontally. And that would enable me to say these two angles are equal. And to number them, let's call those 3 and 4. And that would give us another pair of angles. And what you see going on here would ultimately be a pair of angles, a side, and another pair of angles. So this would be the angle, side, angle shortcut. So in order to do this, I actually need to find the slope first of MN and the slope of LO, which is red. And then I need to find the slope of L to M, which is orange, and O to N, which is also orange. Slope is y minus y over x minus x. So for m to n, I'm going to go 5 minus 5 over 2 minus 8. Well, 5 minus 5 is 0, and 0 over anything is just 0. And then I can go this way, y minus y, 0 over 0 over 0 minus 6. Once again, 0 over anything is 0. Now we're going to do slope, the orange. Again, y minus y. So I'm going to go 5 minus 0, that's 5. 2 minus 0 is 2. And O to n, y minus y, 5 minus 0 is 5. Eight minus 6 is 2. Now I notice my slopes are the same. My slopes are the same, the lines are parallel. So let's summarize what we have here. I'm going to use the I know that because method, also known as the 2 column. Okay, so let's start with the given. I know that 1, L is at 0, 0. M is at 2, 5. N is at 8, 5. And O is at 6, 0. Why do I know that? Because it is given. Now I know the slope of MN equals 0 and LO equals 0. I found that using the slope equation. Because of that, I know that line MN is parallel to line LO. Because these slopes are equal. Now that gave me the red lines parallel, which gives me angle. I had them marked. Angle 1 is congruent to angle 2. That gives me my first set of angles. Why? Because if parallel, alternate interior angles are congruent, also known as armpits of the Z. I also know that ln, the side, is equal to ln. That gives us our side, because that's the reflexive property. Something's equal to itself. It's shared by both triangles. Reflexive. Then I know the orange lines are parallel. That would be LM. The slope of LM equals 5 over 2, and the slope of ON equals 5 over 2, and the reason because is we use the slope equation. Because of that, that gave us sides which are parallel, so I can say LM is parallel to ON, because the slopes are equal. Because I have equal slopes and they are parallel, I can now say those angles that I included, 3 is congruent to angle 4. That's a pair of congruent angles because if parallel, alternate interior angles are congruent. So we take a look, very close look here, it's angle side angle going on. So now I can finally say that triangle LMN is congruent to triangle NOL by the angle side angle shortcut property. So that is an example of a 2-column proof, a 2-column coordinate proof.